Hello, so in this video we're going to look at chapter 7.2, adding and subtracting rational expressions. So there's going to be 5 different topics that we're going to go over. Along with that, in the description below, there will be the video chapters, so you can jump to the various sections that you would like to see. There will be links to the Openstax textbook, the first and second edition, a shared folder that you're welcome to look at with additional resources, handouts, and more, and then a survey at the bottom. So when we're doing adding and subtracting rational expressions, we want a, b, and c to be polynomials, where c cannot equal 0, and so then we get these adding and subtraction rational expressions, where if they have common denominators, they're very easily to work with, and we can manage them. It just depends on when they're not, we have to make them common, and then we can subtract them. And then when it comes to the negative, we want to make sure that when we're using the negative, we want to make sure that we distribute out the negative into the terms in the parentheses to make sure that we can keep it all balanced. So first, we're going to look at adding and subtracting rational expressions with common denominators. So first, we're given 2r squared all over 2r minus 1 plus 15r minus 8 all over 2r minus 1. And so since we're just adding them together, we can write it as 2r squared plus 15r minus 8 all over 2r minus 1. If we factor the top, we get a 2r minus 1 and an r plus 8. And we can keep our 2r minus 1, and we can see that we can cancel, and our answer would be r plus 8. So next we're given 7x squared all over x squared minus 9 plus 21x all over x squared minus 9. So since we're just adding these together, we can do 7x squared plus 21x all over x squared minus 9. If we look at factoring the top and pulling out a 7, we get 7x in parentheses x plus 3 in parentheses all over, and since we have a difference of squares, we would have x plus 3, x minus 3. If we go back to look at what we can cancel an x plus 3 in the top and in the bottom, and we're left with a 7x all over x minus 3. So first we're given these rational expressions and we need to subtract them. So first I would put them all over one bar, so 5m squared minus 13m plus 2 minus in parentheses 4m squared minus 7m minus 18, or excuse me, plus 18. All over m squared minus 64. And so first, we would have to distribute our negative to every item in the parentheses, so every term in the parentheses. And so we would get 5m squared minus 13m plus 2 minus 4m squared plus 7m minus 18. If we combine like terms in the top, we would get m squared minus 6m minus 16 all over m squared minus 64. If we look at factoring, we would get an m plus 2, m minus 8, and then in the bottom it would just be difference of squares, so you would have m plus 8, m minus 8. And now we can go back and cancel, and we can see that we have an m plus 8 in the top and the bottom, and so our answer would be m plus 2 all over m plus 8. So now we're going to add and subtract rational expressions with opposite denominators. So when we have something with opposite denominators, we would take an expression and multiply it by -1 because we want this expression to look like this expression. So we would still have our left expression, n squared plus 6n all over n squared minus 25. With us multiplying by -1 in the bottom and the top, the bottom of our fraction would be n squared minus 25, and in the top we would have a -3n minus 20. We can do what we did before with the common denominators. We can do n squared plus 6n minus, in parentheses, minus 3n minus 20 all over n squared plus 25. All over n squared minus 25. We would take our negative and distribute it out to everything, and so we would get an n squared plus 6n plus 3n plus 20. We combine like terms, we would get an n squared plus 9n plus 20 all over n squared minus 25. If we factor, we would get a positive n plus 4 and an n plus 5, and in the bottom we would get an n plus 5 and an n minus 5. And if we go back and cancel, we could see that an n plus 5 cancels in the top and the bottom, and our answer would be n plus 4 all over n minus 5. So next we're given this expression, and we can do the same process that we've done before. So we can multiply the one on the right by -1, the top and the bottom of the fraction. So we get next we could combine like terms in the top, and we would get 8x squared plus 13x minus 6 all over 8x minus 3. If we look at factoring in the top, we would get an 8x minus 3 and an x plus 2. And in the bottom, we would still have our 8x minus 3. If we go back and look what cancels, we have an 8x minus 3 in the top and the bottom, and so our answer would equal x plus 2. So now we're going to look at least common denominators within a rational expression, and so we're going to be given two expressions. We don't have to add, subtract, or multiply, divide, or anything. We're basically going to find out what we can do with the LCD, figure out what it is, and then multiply it into both of them to make the denominators common. So first we're given the one on the left, and we could factor our denominators. And if we factor both of them, we can see in the top that we would get 2u plus 4, u minus u plus 3. And in the bottom, we would get 2u plus 3, u minus 2. And since we want common denominators, we would be able to see that our LCD would be 2u plus 4, u plus 3, and u minus 2, because we want everything to be counted, and then we'll just multiply in what we're missing in both of them. So if we rewrite our equation, or our example, we can see on the one on the left that we're missing a u minus 2, so we can multiply a u minus 2. And on the one on the right, we can see that we're missing a u plus 4. Multiplying those in, we get a 6u minus 12 all over 2u plus 4, u minus 2, and u plus 3. And on the right, we can multiply a u plus 4 in, and then we get a 5u squared plus 20u all over our LCD. So now we're going to be adding and subtracting rational expressions with unlike denominators. And so now we can use the LCD on both expressions to make them common, and then we can add and subtract them like we've done before in the common denominator section. So first we're given this equation, and we want to make them common denominators, so we could multiply the one on the left by an m minus 6. We can multiply the one on the right by an m plus 6. And we would have a 3m minus 18 on the top and an m plus 6m minus 6. We could do the same thing on the one on the right. We would have an m plus 6m minus 6. And in the top, we would just have an 4m squared plus 24m. Then we would have to distribute our negative, or our minus. So if we do 3m minus 18 minus, in parentheses, 4m squared minus 20 plus 24, we would take our minus and distribute it into both of them. We get 3m minus 18 minus 4m squared minus 24 all over m plus 6 m minus 6. If we combine like terms, we would get negative 4m squared minus 21m minus 18 all over m plus 6 m minus 6. And that does not factor in the top, so we can let it be. So now we're given this rational expression, and we can see if we factor our denominators first. We can see that if we pull out a 3, we're going to have an m minus 1, and on the right, we're going to get an m minus 1 and an m plus 4. So now we want our LCD. We can see that our LCD would be 3m minus 1 m plus 4. So we can multiply the one on the left by m plus 4. And we can multiply the one on the right by 3. And so we would get a negative 3m squared minus 12m all over our LCD. And then we can multiply our 3 in, so we would get a 15m all over our LCD. We can rewrite it out. We would have a negative 3m squared minus 12m plus 15m all over our LCD. If we combine like terms, we would get a negative 3m squared plus 3m all over our LCD. And if we look at factoring for the top, we would get a negative 1, 3, m, and an m plus 1 all over our LCD. We can see that our 3's will cancel, and we can see that our answer would be a negative m squared plus m all over m minus 1, m plus 4. So now we're going to add and subtract rational functions, and so the same process is what we've done in this section. It's going to be the same process just with f of x, g of x, and r of x. So we're given this rational function, we have r of x is equal to f of x plus g of x, and so we're just going to be adding our rational expressions. So if we rewrite them, we would get 2x squared plus 7x minus 28 all over x squared minus 16. We're going to be adding those together to x plus 7, x plus 4, all over negative x squared plus 16. And we can see that we can multiply by a -1 on the right. By multiplying by -1, we flip all of our signs and we have a common denominator. If we add and subtract up top, we can see that we're going to get a 2x squared minus 32 all over an x plus 4 and x minus 4. If we factor the top, we can see that we're going to get a 2x plus 4 x minus 4 all over x plus 4 x minus 4. If we go back and look what we can cancel, we can see that we can cancel our x plus 4s and our x minus 4s, and so our answer would be r of x is equal to 2.